Hello everyone. In this session, we will discuss some problem regarding the transistors. In this first problem here, for the given circuit, assume VB1 equal VEB2 equal 0.7. So this voltage and this voltage will be equal to the 0.7. The value of the DC voltage VC2 is, so here this is the VC2. He is asking to find out the VC2. First, in order to find out the VC2, we need to know the current flowing in this branch. Assume the current flowing in this branch. This is the transistor 2, Q2. So current is, take it as IC2. And first we need to find out this current. Understand? So we need to find out this current. We need to better to find this current in this. That may be the, we need to find out the current IB2. Yes, to find out this current we need to find out the voltage here VB2. In order to find out this voltage VB2, we need to find out this voltage means we have, this is VE1, this is VE2, both VE1 and VE2 both are same. Yes, so we have to reverse the procedure. So for that purpose, we know that in order to find out the VE1 or VE2, better we know that this voltage is nothing but, this is the base voltage, that nothing but VB. Yes, VB. So already you know that VBE1 is equals to 0.7. That means the voltage between this point and this point. That means VB1 minus V1 equal to 0.7. What is VB1? VB1 is nothing but this voltage. So 2.5 minus VE1 equal to 0.7. From this, VE1 equal to 2.5 minus 0.7. So we can take 1.8 volts. So voltage across this point 1.5 volts, nothing but VE2 equal VE1 is equal to 1.8 volts. So this voltage is, we know that, but V and the voltage VEB2 is already given the 0.7. That means voltage between these 2 points. So VE2, I can write VE2 minus VB2 equal to 0.7. You know already VE2 is 1.8 and VB2 we need to find out. From this, VB2 equal to 1.8 minus 0.7. The voltage value is 1.1 volts. So we got the VB2. Now we will find out the IB2. From here the IB2 value equal, so IB2 value equal this voltage minus this voltage by this drop. So VB2 minus 1 by 10K. What is VB2 here? The VB2 value is already 1.1 minus 1 by 10K. So the value is we can write 0.1 by 10K amps. This is the IB2. Yes, so we already got this IB2 current. We know the relation between IB2 and IC2, that is IC2 will be equal to the beta times of IB2. So here beta value is, so beta 2, he is given beta 2 but he is not mentioned here, but beta 2 value we should write beta 2. Here beta 2 value is, we will take the 50 here. So by using that, so IC2 equal beta into IB2. Beta value, you know that the 50. What is IB2? IB2 0.1 by 10k. So from this we can find out the VC2. VC2 equal IC2 into the resistance. So here this is the IC2 and this resistance. So this resistance is 10k. So IC2 is 50, not 50, this is 5 by 10k into the resistance is, what is the resistance value here? This is not 10k, this is 1k. So 1k. Okay, so we can write the voltage across this drop is 0.5 volts. 0.5 volts. So this is the procedure to find out. The problem is like this. Okay, so look at the next problem. The next problem is, the second problem is, for the given circuit, if the voltage across 3.3 kilo ohm is 5 volts. So where is the 3.3 kilo ohm? Here. This is the 5 volts and VEB equal to 5 volts. So this is E emitter and this is the base VEB. Yeah, okay, VEB cannot 5 volts. This is wrong actually. This is 0.7 volts. Beta equal 100. Beta amplification factor is 100 is given. Then the value of R2 in kilo ohms. So he need to find out the value of this R2. So for that purpose, we need to find out this current, we need to find out this resistor. That means we need to find out this resistor, we need to find out this voltage, okay, and we need to find out this current also. We will take it as I2 current, and for that purpose, and this current is nothing but combination of two currents, the current from the I1 and the current from the base current. So first we need to find out this base current and we need to find out the current I1. The adding of the both currents I1 plus IB, we will get this I2 current. So for that purpose, first we need to find out the collector current here. How we can find out the collector current? This is the VC by 3.3k. So I will write the collector current IC equal to voltage, this drop plus this resistance. Drop is 5 volts and resistance is 3.3k. The value is 1.515 milliamps. So now we will find out the beta here. Base current. Amplification factor already given. The base current equaled collector current by beta. So what is the collector current? So collector current value is 1.515 by beta value is 100. Okay, so we can write base current IB equal 15.15 milliamps. This is milliamps. 15 milliamps, not milliamps. This is microamps, right? So base current is completed, and we can find out the emitter current also from here. We can find out the emitter current from this point. That emitter current we can write like this: beta into IB plus base current. That means 1 plus beta times of base current. So 1 plus beta is 100 into base current 15.15 microamps. From this we can write the emitter current value is 1.53 milliamps. So emitter current value also we will find out. Now we will find out the emitter voltage. The emitter voltage. So we will find out this emitter voltage. So emitter voltage value equal how we can find out the emitter voltage? Simply, so at this point voltage is 12 and we know the current value, and we will find out this emitter voltage. So that is 12 volts minus IE drop by IE drop, yes, 12 volts, this voltage minus this drop. So 12 volts, what is IE? 1.53 milli is IE, and RE is 1.2K. 1.2K. By doing the calculation, we will get emitter voltage is 10.16 volts. 10.16 volts. Why we are finding this emitter voltage? In order to find out the base voltage. Yes. So from this, look at here. Already he given VEB is 0.7 volts. VEB equal to 0.7 volts. You know VEB minus VE minus VB equal to 0.7 volts. V is 10.16 minus VB equal to 0.7. From this we can write the base voltage is 9.4 volts. 9.4 volts. Okay. So we have two currents. We know the VB value also. And we need to find out this I2 current. So before that, we will find out I1 current. First we need to find out this I1 current. So I1 current I can write like this. The I1 current value equal this drop minus, in order to find out this current, this voltage minus this voltage by this resistance. So that is 12 volts minus VB by R1. So 12 volts minus VB means 9.46 by R1 is 4.7K. So by doing the simplification, we will get the I1 value is 0.539 milliamps, or we can write I1 equals 539 microamperes. So we know the I2 value and the IB value. By adding this, so we know the I1 value and the IB value. So by adding this I1 and IB, we will get the I2. So therefore I2 current will be equal to the combination of I1 plus IB. So I1 is 539 micro plus IB is 15.15 microamps. So combining together we will get 554.76 microamperes. This is the I2. So here we know the current entering into the I2, and we will find out, and we know the VB value. So by using this we can find out the R2 value. So from that I can write directly VB is nothing but I2 into R2. So by using this we can write the I2 value equal, not R2 value, R2 value equal to VB by I2. So where is the VB? VB, you know the VB value 9.4 by I2 value is 554.76 micro. So by using this we will write the R2 value equal 17.06 kilo ohms. 17.06 kilo ohms. Okay, so this is the procedure to find out this type of problems. Okay, so the next problem is, look at this problem. For the given circuit the transistors are perfectly matched. So look at here, we have three transistors. This is one transistor, this is the second transistor, and this is the third transistor. Beta of the transistor is very high, so beta is high, very high. If the forward voltage of the diode drop is 0.7 volts, so this has the 0.7 volts drop. Okay, this is the drop, diode drop. Okay, drop of diode is 0.7 volts. Then the current I in the circuit, this is the current I in the circuit. So he is asked to find this value. Just observe here, this is the one transistor, we have the two transistor. If you clearly observe this transistor, the transistor base and collector combined together, and these current will be supplied to one base and another current will be supplied to the another base. Yes, that means here this look like a current mirror circuit. This is the current mirror circuit. So in that current mirror circuit, what do you know that the current in this, just take it as I reference. This is a source, that's why this is I reference. Current will be equal to the I1 current as well as I2 current. So that's total current will be nothing but combination of I1 current and I2 current. So in order to find out this current, first we need to find out the reference current, and both the currents will be equal to both the currents I1 and I2 currents will be equal to the reference current. So to find out this reference current, we have to do the calculation. So we know that here this is the base and this is the emitter. Okay, this drop, we know that the drop value VBE equal 0.7. VB equal 0.7 and drop across V is minus 5 volts. Minus 5 volts. So we should apply some, we will write the VB value, that VB equal VBE plus V. In order to find out this drop, the combination of this drop plus this voltage, VBE is general diode drop 0.7 plus VE is the minus 5. So the VB value is the minus 4.3. So this voltage is minus 4.3 and this voltage also the minus 4.3 volts. Both voltages are minus 4.3 volts. So from this we will write this, we need to find out this voltage drop. So we need to find out this voltage drop VD. Take it as this voltage drop generally. So find out this voltage drop. So just look at here. From this I can write VD equal, VD means the drop between this point and this point, minus 4 VD. I can write the VD equal minus 4.3 plus 0.7, 4.3 plus 0.7. Up to this the voltage drop is the 4.3. okay, but this drop, by adding this 0.7 we will get that value. So the value is minus 3.6 volts, minus 3.6 volts. Assume the current flowing in this branch is I dash. From 0 to this is, assume the current I dash. So we will find out the current I dash value is this voltage drop minus VD by 1K. So ground voltage minus VD by 1K, 0 by, you know the minus VD value is minus 3.6 by 1K. So we will find out I dash equal 3.6 milliamperes. So here this current value is the 3.6 milliamperes. But here the beta value is very high. But one need to find out the current in this reference current, but beta value is very high. Wherever the beta is very high, beta is very high, he mentioned already in the problem. So wherever the beta is very high, generally the base current will be equal to the collector current by beta. Okay, whenever beta is very high, IB value is very low. IB value is very low, approximately equal to 0. That means, look at here, the current entering into this value is approximately 0, or this value is approximately 0. Then the current value entering into approximately is 0. Then the total current will be entering into the reference current. So we can write the total current, reference current is nothing but I dash. Reference current is I dash. Here you know the I dash value is 3.6. So I can write this is the 3.6 milliamperes. 3.6 milliamperes. So here, but what do you know that the total I1 and I2, this is the current mirror circuit, so that's why I1 and I2 is nothing but the reference current. Reference current value is the 3.6 milliamps. So from this current I equaled I1 plus I2, that is 3.6 milli, 3.6 milli, that's why 7.2 milliamperes. The total current value is the 7.2 milliamperes. Okay, so this is the current flowing in the given transistor. Current flowing in the given transistor, that is the 7.2 milliamperes. Okay, so these are the some different models of problems of the transistor. I hope all of you understand the session. Thank you.